Okay, so we're going to start off by reviewing the Maclaurin series that I suggested you memorize because you're going to need them. So when we have e to the x, just to remind you, that's 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus yada 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 plus x to the n over n factorial plus dot dot dot. It's equal because this is a series. And remember the series notation was n equals 0 to infinity of x to the n over n factorial. Okay, then we had sine x, which was x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. This is an alternating series. Plus, then the general term could be negative 1 to the n times x to the 2n plus 1 over 2n plus 1 factorial plus dot dot dot. So in the sigma notation, that would be sine x equals sigma n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over the quantity 2n plus 1 factorial. Then we had cosine x. These are Maclaurin series, all right? Just so we have cosine x, 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot. So that is, the general term is negative 1 to the n, x to the 2n over 2n factorial. This is if it's indexed at 0. So cosine x is the sum from 0 to infinity of negative 1 to the n, x to the 2n over the quantity 2n factorial. And then you're going to want to know 1 over 1 minus x, which is 1 plus x squared plus x cubed, dot, 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 x to the n. So 1 over 1 minus x, sigma n equals 0 to infinity of x to the n. Okay, you have to have these memorized. All right, so when you're looking at these Maclaurin series, you can take these series, and these series behave like the functions that they represent on their interval of convergence, okay? So on their interval of convergence, okay, these series function okay, just like the function itself. These series behave, I don't like using function twice, behave like the function themselves. Just like the functions themselves. Okay, for a series with a finite interval of convergence, okay, such as 1 over 1 minus x, taking the derivative or integral will not change the radius of convergence. But may change the endpoints. of the interval of convergence. Okay, so we can manipulate these series, okay, to suit other similar non-polynomial functions. Okay, you can manipulate these. Here's the manipulations. Okay, you can substitute into a series for x. Okay, so in other words, let's say you're trying to find e to the 2x. You write out the series for e to the x and then replace all the x's with 2x. You can multiply or divide the series by a constant and/or variable. So let's say you have x times e to the x. You just write out the series for e to the x and then multiply by x. Okay, you can add or subtract two series. So let's say you wanted to find the series for e to the x plus e to the negative x. You could just add e to the x, then take e to the x, replace each term with negative x, and then add them together. You can differentiate or integrate a series, okay, which may change your interval of convergence, okay, but not your radius. So you could gain or lose an endpoint is what that means. Okay? And then we can recognize the series as a sum of a geometric power series, which we'll be doing in our next video. Okay, let's take a look at some examples. Okay, so let's say you have the following series. You have e to the x written out, 1 plus x squared over 2 factorial, but they don't have to tell you it's e to the x, okay? They just give this series written out. And then they ask you to find f prime of x. So when you're getting the derivative of e to the x, the series itself, it's going to behave just like the derivative of e to the x. So the derivative of e to the x is e to the x. Well, it's the same with the series. Go ahead and try it. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared over 2 factorial is x. The derivative of x cubed over 3 factorial is x squared over 2 factorial. So you see you're going to get the same series. All right? Now, if you want to find f prime of 0, right? Let's say you would see that it's just 1, all right? Which makes sense because the derivative of f is e to the x and e to the 0 is 1. Okay, let's take a look at integrating. So we just got the derivative of a series. Okay, let's say we have f of x equals negative x plus x cubed over 3 factorial minus x to the 5th over 5 factorial plus negative 1 to the n plus 1, x to the 2n plus 1 over 2n plus 1 factorial. Okay, number 1, do you recognize what this is? All right, it's negative sine x. So just keep that in your back pocket. Then let's say they tell you capital F of x is the integral of f of x dx. And they give you an initial condition, capital F of 0 equals 1. Find capital F of x. So you would integrate. The integral of f of x dx would be the integral, all right, of negative x plus x cubed over 3 factorial minus x to the 5th over 5 factorial. Okay, so keep in mind, you have to bump it up 1, right? So when I bump it up 1, I'm going to get negative x squared and then divide by that number. When I bump up the x cubed, I'm going to get x to the 4th, but then that's going to become 4 factorial minus x to the 6th over 6 factorial. The negative 1 to the n plus 1 just stays. But then you're going to have x to the 2n plus 2 over 2n plus 2 factorial, yada, 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 plus c. All right, but we know that we're going to substitute in this initial condition. So when I do that, right, so this is f of x. So we have 1 equals, all of these are going to be 0, 0, 0, 0, 0, plus c. So therefore c is 1. Okay, so therefore f of x, we have to put a 1 in front of this, is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. Okay, what is this? Well, this is cosine x, right? So f of x is cosine x. Okay, why does that make sense? Because if we integrate negative sine x dx, we get cosine x plus c. So it makes perfect sense. All right. Okay, pause the video and copy down this question. Find the Maclaurin series for f of x is sine of x squared. Find the first 4 non-zero terms and the general term. Okay, so this is just going to be substitution. So first we write the Maclaurin series for sine x, which is x minus x cubed over 3 factorial, x to the 5th, 5 factorial, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial, yada, yada, yada. Okay, so you know that this sum, we already know the sum. All right. The sum is n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial, right? Okay, so now we're going to plug in x squared. So term by term, you replace x with x squared. Well, x squared to the 3rd is x to the 6th. X squared to the 5th is x to the 10th. Okay, so the negative 1 to the n stays, but then that's going to be x to the 2 to the 2n plus 1. So when you distribute, that will be 4n plus 2 over, all right, nothing happens to the denominator here. Okay, so keep that in mind, because x squared to the 2n plus 1 is x to the 4n plus 2. Okay, so just be careful with that. So this is your general term. So we want the first 4 non-zero terms. Hold on, I need to do one more. Okay, so the 4th term of sine x is minus x to the 7th over 7 factorial. So that means the 4th term of sine of x squared would be minus x to the 14th over 7 factorial. All right, kids? Okay, let's say we want the Maclaurin series, okay? Find the Maclaurin series for g of x equals x cosine x. So first, and we'll do the first 4 non-zero terms. Okay, and the general term. So first you write out that cosine x, the Maclaurin series for cosine x, 1 minus x squared, 2 factorial, x to the 4th, 4 factorial, minus x to the 6th over 6 factorial, general term, negative 1 to the n, x to the 2n over 2n factorial. So now I'm just going to multiply everything by x. So x cos x is just going to be x. Everything's going to go up a power. So then we're going to have, when we multiply by x, it's going to be negative 1 to the n, x to the 2n plus 1, because there's one extra x, 2n factorial, yada, yada, yada. Okay? All right. I need to go to the next page for this one. So we're going to do the Maclaurin series for e to the x plus e to the negative x divided by 2. Okay, so e to the x is just 1 plus x squared over 2 factorial, x cubed over 3 factorial. Okay, yada, 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 right? Now we're going to sub in negative x. So we get 1 minus x, but the even terms stay the same. Minus x cubed over 3 factorial. Okay, so now they're alternating, so we have negative 1 to the n. Then we have x to the n, that stays. And then that's over n factorial. Okay, so now we're going to add these together. Look at what's going to happen. You're going to get e to the x plus e to the negative x is going to be 2. All the odd terms are going to cancel out, kids. Plus 2x squared over 2 factorial, right? Then your x to the 4th over 4 factorial would become plus 2x to the 4th over 4 factorial plus 2x to the 6th over 6 factorial. So then it would be 2 times x to the 2n over 2n factorial. There are no negative terms. And then we need to take half of this. So e to the x plus e to the negative x, then divided by 2, just becomes 1 plus x squared over 2 factorial, x to the 4th over 4 factorial, x to the 6th over 6 factorial, x to the 2n over 2n factorial. Okay? All right. Okay, kids, that concludes this video. I think that's enough. So, again, just remember that you can sub in, you can multiply, you can divide, you can get derivatives, you can get integrals, all right? And the whole using initial conditions works again as well. All right, thanks, guys.